great, as always, to see you here. We're going to get started in just a couple of minutes as we wait for the YouTube Live to begin. Ooh, and I hear my own voice in the background, which is very disconcerting. So we're going to give people a few minutes to join. I'm going to tweet that we're going to kick off here shortly. And for those of you who've already joined, welcome. Bear with us. We're going to get started with the 23.11 community call here in just a few moments.
Welcome. I see a lot of people already joined, and I'm especially happy to see regular visitors. Hi, Ellen, and another Ellen. Hi, Bharat. And thank you for your contributions, especially in this release. Hi, Chris, and Christian, and Christina, and Eugene, and Mingfei, Jia, and Nevan, Nikolai, Roman, Sante, Stefan, Todd, Valery, Andreas, Brian. We will start in 30 seconds. And you still have time to invite your friends in Zoom or on YouTube. We have live translation. And you can ask your questions right here or on YouTube. And for the best questions, we will send you what, Tyler? Do you know?
A t-shirt.
A t-shirt. Like this t-shirt, where we have a new.
Yeah, I think it's actually that one while we have the new ones being updated. I'm sorry about that. I just had the delightful experience where, unfortunately, living in sort of a compact space in the Netherlands, my stream connected to my daughter's AirPods. So I was like, I can see Alexei's face moving, but I can't hear words.
Oh.
Amazing. So we are live on YouTube. We're continuing to see people roll in here in chat. I think we'll go ahead and get started, Alexei, because I've seen a preview of the deck, and there's quite a bit to cover. So let's go ahead and kick off. First, I want to start by welcoming everyone. Thank you so much for joining us on the monthly live ClickHouse community call. This particular iteration, we have the opportunity to chat about 23.11, a few housekeeping items. Chat is there. We'll keep an eye on it. If you're joining us on YouTube, please feel free to use YouTube chat. We'll keep an eye in that location as well. So with that, Alexei, I'm going to hand it over to you.
Thank you. Let me share. Okay, so this is ClickHouse release 23.11. It is just a monthly release for November, and we will have most of the time for new features and improvements and everything else, and maybe just a few minutes for your questions, I hope. But there is a lot of features, so let's not waste time. We have 25 new features, 24 performance optimizations, and 70 bug fixes. So what do we have? Let's start with some small and nice features. Something that you might find not needed for you, but someone else will find really useful. The first is the possibility to create an index and materialize the same index in the same alter query. You know that if you create an index after the table is already created, this operation will make the index effective only for new data that will be inserted after creating the index or merged after creating the index. The old data parts will not contain the index, so the queries will not benefit from it. And to create the index to backfill it for the existing data, you use alter table materialize index. In the previous versions, if you do this alter query and try to create an index and at the same time backfill it, you will get an exception. And it was quite disappointing. It was also disappointing for me. So we fixed it, and now it works. It works perfectly. You can do it. It looks like a small thing, but you will find it useful. Another small and nice feature. The concat function now works with whatever data types, any data types, not only strings. In previous versions, you have to convert data to strings before passing to the concat function. In the new version, just type whatever, and it will be automatically converted to string. You can even pass arrays, tuples, anything. As a small bonus, now we also support concat with just a single argument. And it does nothing. And so you pass a single argument and it just returns this single argument. And you might be wondering, why do we need it? It is a question. Do you know why do we need this function variant? I will give you about 10 seconds to type your answer in the chat or on YouTube. So, do we have any answers?
No, we do not. We don't. Oh, we do, in fact. For rows where some columns are missing, or for dynamic strings, this posits that it's simpler to avoid checking for a case where you have one element in an array. Prepared statements is another possibility, or select columns of different types.
So basically, no, the answer is incorrect, and the other answer is also incorrect. Do we have any more hypotheses?
Arbitrary parameter length passing?
Maybe, but no. Let's ask an expert. We have an expert in Zoom, Dale. Dale, do you know why do we need to support concat function with just a single argument?
I can't imagine. I can't, other than possibly compatibility with other syntaxes. I really can't see why we would need this. I'm sorry.
And this answer is correct.
Oh, fantastic. There you go.
Yeah, this is for compatibility with MySQL dialect. So MySQL, for some reason, does support for this function variant. And for some other reason, some business intelligence tools like Tableau or QuickSight generate the queries with this this function overload. So now we have it, and now Tableau and QuickSight works. So the next small feature, a new virtual column for external tables, _size. ClickHouse has support for table functions and table engines to work with external data on S3, on HTTP servers, in the file system, HDFS, or even Azure Blob Storage. It can process arbitrary datasets as data lakes. And it is quite convenient. You don't even have to load this data into ClickHouse. You can process it straight ahead. And we already have a few virtual columns. So virtual columns are not the columns from the dataset, but the columns about dataset, like metadata. And we already have the columns _file and _path. So when you process multiple files, you can get the metadata about them. And now another column _size, and guess what? It will give you the file, the size of the file. So nothing surprising. And to prove that it is nothing surprising and uninteresting at all, I will show you a demo. Because I'm really interested if it is boring enough. So let me open my terminal and go to a random server and copy paste the query. And this query works. And it is fast, 5 gigabytes a second. And for the second time, it is even faster, 10 gigabytes a second. And I have 100 of files, and I can get the size of every file. So yes, it is boring. Let's go back and continue my presentation because, yeah, this feature is uninteresting. This is for you. Another feature, a new table function, file cluster. It is similar to other table functions like S3 cluster, URL cluster, HDFS cluster, and Azure Blob Storage cluster. All of these functions are similar to the S3 table function that I showed to you. But if you have multiple servers, and these servers form a cluster, you can specify the name of this cluster. And these table functions will split the tasks and assign the tasks for particular files to different servers. And everything will be processed in parallel. And the file cluster table function will process files from the local file system in parallel, but assuming that for some reason the local file system has a view on a shared set of files. And this is the case when you mounted a network file system like NFS or EFS in AWS or whatever distributed file system, Ceph, MooseFS, whatever. Hopefully it will work. And basically it is the same as S3 cluster, but for distributed file systems. Yet another boring feature. A new setting, preferred optimized projection name. It is like a hint for optimization. If you don't specify this setting and you query your data from a table with multiple projections, ClickHouse will automatically select possibly the best projection from its standpoint. But it might be not the best projection from your standpoint. So with this setting, you just specify what projection do you prefer for optimization. And ClickHouse will not try to be smart and just use this projection if it exists. It is pretty simple. Yet another not so boring feature. A system table named Blob Storage Log. This table is intended for auditing all the data that was written to S3 by the tables that are using S3 as a virtual file system. So you configure ClickHouse with separation of compute and storage. It will write data on S3. Data on S3 will be stored as a set of blobs with arbitrary names. And you have metadata about this data in the local file system. What to do if you lost the metadata and want to recover it? You are happy if you have backups. But if not, configure this table. And maybe this table will save, I will not say what, but it will save you. So quite a useful table. A few improvements for ClickHouse Keeper. I hope you use ClickHouse Keeper because today there is absolutely no reason to continue using Zookeeper. ClickHouse Keeper is better in every regard. And after these improvements, it becomes even better. So the first improvement is a special command to yield leadership. And it is useful for operating Keeper in dynamic environments like Kubernetes. When you frequently want to change the size of your pod, or you want to install the new version and automate everything. Actually, I will prefer if you will stay boring, don't use Kubernetes with Keeper, because there is a lot of chance to misconfigure something. If you use plain old boring servers or virtual machines, it is safer. But okay, you want to use Kubernetes, you want troubles, you subscribe to these troubles, and this feature is specifically for you. So it makes the operation of Keeper safer. When you want to decommission a node or change the pod size, first you might want to yield the leadership if Keeper was a leader on this node. Then to wait when a new leader will be elected and appear on another node. And only then shut down this node. It makes sense because you will make sure that every moment of time there will be at least 2 nodes, and you can safely replace the existing node. Another improvement is optimization for network communication. You can simply enable compression for the network protocol. It is controlled on the client side, so on the ClickHouse server, just specify use compression true. So you will expect at least several times less network traffic. And it makes sense if you have a lot of tables, a lot of inserts in ClickHouse. And keep in mind that it is extension of ClickHouse Keeper. You will not find this feature in Zookeeper. It simply does not exist because ClickHouse Keeper is better. It is so nice, and we can continue optimizing it and continue, and it will be further away from Zookeeper. And yet another feature for Keeper, introspection of availability zones. So in the configuration, you can specify availability zone either explicitly like this or with auto detection. And with auto detection, it will support the metadata service IMDS v2 on AWS and a similar service on GCP. So it will automatically determine the availability zone and expose it inside this node in Keeper. So your clients can query it and prefer to connect to the nearest Keeper to save network traffic and the cost of this traffic. Okay, what's next? What about performance improvements? Let's see. The first is kind of strange. It is the support for indexes on the system numbers table. But what is the system numbers table? This table is not stored anywhere. It is completely ephemeral. It generates the data. So what does it mean? Index on system numbers. Let me check. Let me show you a demo. And I hope you will be able to see it. So first, let me try it with the old version. And I have a few of these versions. For example, 23.8. And let me try this demo. I should copy paste it directly from the slide. So this query, we will select just a few numbers, 3, 4, 5, 10 billion, no, 1 billion and 456. And it selected 4 of these numbers and continue working and continue. And I don't know why, because I asked it, I want these numbers, nothing else. Cannot it be smart? Let's try with a new version. The same query, and it works instantly, and it does not do any pointless work because it is optimized. So this is pretty neat. Small but nice optimization. Okay, maybe you don't need it. Let me show you something that you might need, actually. Parallelization of window functions. And the explanation is pretty clear. So in the previous version, window functions were slow. In the new version, window functions are fast. How can I convince you? Let me try to show you at least something. Okay, let me start with the old ClickHouse version, and I will create a table, this table. So it is a merge tree table with some random numbers. Okay, it is inserted, and now some query with window functions. And here is a single window function over partition. And it also contains group by this partition. But let me just check how long it will take. 1.3 seconds. Not bad. It is fast. ClickHouse was fast already. What to dream about? Maybe it was fast enough. I don't know. Maybe we don't have to implement these optimizations. Let me try with the new version. Okay, the data is inserted and the same query. 0.4 seconds. So 1.3, 0.4. And now tell me, do we actually continue to do this kind of optimizations? I don't know, your choice. If you will tell me, please stop optimizing ClickHouse, it is already so fast, we don't want it to be faster. Tell me, and we will stop. So, Tyler, do we have any impressions?
Yes, and my general impression is that regardless of what people say, we won't stop. But we see hearts, we see clapping hands, we see smiling faces. Listen, 1.375 to 0.407, it matters.
Yeah, it does matter. Okay, another optimization. Asynchronous loading of tables. So, one question again for you. How long does the server, ClickHouse server, take to start up on your production? In my production, it takes less than 1 second. And I can show you, but your knowledge may vary. Maybe you have 100,000 of tables and it will start up for a whole day, but you should not have 100,000 of tables. You should not have even 10,000 of tables. It is not natural for ClickHouse. ClickHouse can work with just a few tables with trillions of records. But I don't want to judge you. Maybe you can still use ClickHouse with 100,000 of tables and be a reasonable person. So now we have an optimization for you. Just enable a new configuration option, async load databases. And ClickHouse will start instantly. So what it will do? It will start accepting connections instantly. And at the same time, start loading of all these tables. And you can already send queries to ClickHouse. If the table is loaded at the moment of query, the query will be run straight ahead. If the table is still in the queue, it will be put in front of the queue. And the query will wait for initialization of this table. So if you have just a few tables and the server takes long time to start up, this feature will probably not help much. But if you have a lot of tables, it will help a lot. Yet another optimization, concurrency control. So concurrency control exists in ClickHouse for maybe half a year, and I already covered this feature on one of the previous webinars, but now it is enabled by default. What it is? It is a configuration to automatically adjust the number of threads per query when you have a high number of concurrent queries. Imagine you have several thousand of concurrent queries at the moment of time. And you don't want every query to try to use hundreds of CPU cores. Probably it will be better if every query will use just a single CPU core. And this feature does exactly this. And you will get high QPS without performance degradation. And you have to do nothing for this. It is enabled by default. A few more optimizations. Optimization for reading from S3 by aggressive retries. So when you have a server like bare metal server, and you store data on SSDs, and you control everything, and you like to control everything, and you monitor everything, and it is your server, and you really like this server because it works, and it is under your control. Okay, you are happy. But if you use AWS S3 for the storage, you will often think like this. You have ClickHouse. ClickHouse is such a wonderful system. It is always fast. It works nicely, but it has to do requests to some unknown service implemented by some other engineers. And that service is behind the network. And you don't know where it is. You don't know how this service exactly stores the data. And you don't know if this service will ever answer to you. Sometimes it answers in 50 milliseconds, sometimes in 500 milliseconds. Sometimes it will waste 30 seconds to answer, but it should not be the case anymore because we will interrupt the request and try another request. So now we will not have large tail latencies. And another optimization is optimization for reading from the local file system when you use it as a cache for remote file system. And the trick here is to read from the local disks in the same way as you usually read from the local file system. So don't try to parallelize as much as for S3. Probably do more 6. Don't read excessive amount of data. Read synchronously if the data is also in the memory. And it is faster. Okay, now about a little bit more interesting features. What do we have? The new experimental feature, column statistics for optimization. So let me show what is happening here. In ClickHouse 23.11, you can specify statistic for every column, and you specify some type of the statistics. It is similar to, say, codec, and you can add the statistic after you create a table, drop or clear it, or materialize statistics to backfill it. It is also very similar to, say, data skipping index. And if you have this statistic, you can also enable an optimization. And then the server will automatically determine selectivity of conditions. And depending on this selectivity, it will reorder conditions to choose the optimal processing order for multi-stage pre-wire optimization. But this is just the beginning. It can be also used for join reordering or for making low cardinality data type not a data type, but automatic decision. And the difference between statistics and data skipping indexes is that all the statistics for all the columns are collected in a small single file for every data part. It is just a summary for every column, that contains statistics. So you don't have to worry about additional disk read. It is very lightweight. Okay, and now something really interesting. In ClickHouse 23.11, the experimental S3 queue feature is promoted to production ready. So this feature is not new. It was announced in the version 23.8, but it was under the experimental flag for a while, and now we are ready to make it available by default. So what it is? It is a table engine for continuous consumption of a bunch of data files from S3. The case is when you have a bucket and the blocks or files or objects, whatever you how you want to name it, constantly appear in this bucket, and you want to subscribe to this set of files. Similarly, how you subscribe to Kafka, but with S3. And you do it like this. You create a table with engine S3Q, specify a pattern for files. You specify a destination table, like just a merge tree table, where the data should appear. And you create a materialized view that will push the data into destination table by subscribing to the queue. And as soon as new files will appear, they will be processed. It supports parallel consumption, distributed consumption on multiple servers, and it can track the set of processed files in either unordered mode or ordered mode. In unordered mode, it will record the set of processed files and don't process them later. In the ordered mode, it will record just the maximum file name of the processed files and skip all the files that are less. Okay, let me show you some usage example. And for this, let's subscribe to a service in AWS named Spot Instance Data Feed. So you probably know what is Spot Instance. It is the instance that, like a special pricing for instances that can be interrupted at any moment of time. But for these instances, you pay less. But the price for the instances is the market price that can go up or down. And you might want to be aware what is the actual price, what is the history. And for this, there is this subscription that you can create in AWS. You create a bucket, you specify this bucket, and the subscription is configured. Okay, and it looks like this. So in your bucket, the files will appear out of nowhere, quite small files, like several kilobytes in GZ format. let's preview this data, and it is quite easy. It is very simple. To preview the data, you can select from S3 table function. And you don't know what is the data format, and when you don't know, I recommend to use the format line as string. And the format line as string represents the file as a table with a single column line of type string. So in the preview, we can see that it looks like TSV. So here is tab, another tab, but you have a strange format with 2 extra records, 2 headers. Typically, TSV or CSV has only a single header record, but it's not a problem. You can tune it with some settings, like input format TSV skip first lines equal to 2. And we will use schema inference, and the file will be represented as a set of columns like C1, C2. And we will also parse these columns. We will parse date time from the first column. Yes, from this format. It is similar to ISO 86, whatever. It is similar to ISO time format. And this is another field, and we have to split it by this character and another field. Okay, it's quite easy. We will parse it with a regular expression and then split. And then parse the prices, like market price, the actual cost for this period of time, and the on-demand price that could be if the instance is not a spot instance. And we will do the aggregation. So we will get something like this. Like we spent $300 for 300 of hours for this instance. Maybe it is not good. Okay, but this is just a simple batch query when I process all the files at once. I want a streaming query. For this, I will create S3 queue. I will specify the same URL, the same parameters for parsing, some parameters for the engine itself, like unordered mode, because files are, we want files to be processed in parallel. We will enable logging, then we will create a destination table, and we will use a small trick. We will do create table S, and it will automatically infer the structure. But we don't want to insert in this table, and we specify create table empty S. And then we will create materialized view with the same structure, selecting from the queue. And after this, everything starts to work. S3 queue will pull the data from S3, process it, and push into our destination table. So we can monitor it with a system table named S3 queue. And so far we have 1.8 million processed records. And we can look at every file processed from this system table. And finally, we can use this table as usual, and it will be fast because everything is stored in ClickHouse in merge tree. So here it is. It works surprisingly. And after I saw how good it works, I decided to make it production ready and remove the experimental flag. Okay, just a few things as a bonus. When you install ClickHouse, You can use this small command. I always use it. It is so convenient. You don't have to install any packages, and it works everywhere. Linux, macOS, FreeBSD. But the disadvantage, in the previous versions, it downloaded 500 megabytes. In the version 23.11, it is just 107 megabytes. And trust me, I will find how to get rid of this 7 megabytes. I almost did it. I still have to do it, but maybe it will be for a new year. For the new year. Okay, what about integrations? First, DBT. Mainly, it is about compatibility with the new versions. Tableau. Tableau Online finally works with ClickHouse. It uses MySQL compatibility protocol, but it looks like we finally implemented everything, even concat with a single argument. So now it works. And a few changes for Kafka connector, like the support for CSV, TSV. It is external Kafka connector, external integrations, and a few updates for client drivers, Python, Node.js, and Go. And a lot of good stuff in our blog. For example, reg pipelines with ClickHouse. Did you know that ClickHouse does reg? Do you know what is reg? I will be surprised if you don't. Because if you go to the street and just listen to strangers on the street, they will talk only about reg and AGI and Gen AI and everything. And you can do reg with ClickHouse. Another interesting blog, and it is quite visionary, like our vision on the future of cloud data warehouses. It is named Unbundling the Cloud Data Warehouse. So if you want to also get a vision and become a visionary, read this article. And a few other quite practical stuff like building a security data platform, enhancing Google Analytics, and a lot of stuff on YouTube. So thank you, and we have about 10 minutes for questions.
I suppose I'll take them, Alexei. Also, your blog post on, well, our joint blog post on local sensitive hashing with projections is just gone live. So you can also recommend that one for people that want to be impressed by your SQL skills.
Wow, my blog post live. This is amazing.
So we've got a few questions. Let's do an easy one. How, if the download size is 107 megabyte, how much memory does it actually take to load ClickHouse into memory? That's a kind of quiz question for you.
It takes about like 300 megabytes. And let me explain what happens there. So 107 megabytes is compressed binary. It is self-extracting, so it will extract to about 400 megabytes. But out of these 400 megabytes, there are loadable sections that will be memory mapped on load. And most of these sections containing the code, and most of the code will be used. So most of these several hundred megabytes will be required in memory. And about 100 megabytes for everything else, like symbol tables, symbol names, that is usually unneeded at runtime. So you can successfully run ClickHouse on a server with 1 GB of memory, and some people even told me they run ClickHouse on a server with 500 megabytes. But I don't think it's realistic, but it is possible.
Okay. Questions specific to the S3 queue. I suppose it's kind of obvious. Dan pointed this out, but files are only processed in parallel if you use unordered mode, right?
Yeah, if you use ordered mode, you cannot. They will not be processed in parallel on a single server, and you should not use it to parallelize with multiple servers, because then the order will be violated. So you have to use unordered mode if you want distributed or parallel processing.
Okay. And how do we detect new files? Does it just involve a periodic relisting of the bucket?
Yeah, we just periodically listing the bucket. So if you have millions of files in your bucket in a prefix, it will be quite suboptimal, but you don't have to worry. Like, it will try to list all 15 or whatever, 10 millions of files. It will take time. It will select new files, process them, and then it will repeat. So it will continue.
And I see that there is a polling. Well, the other question was how often we poll, but I think that's configurable, isn't it? Last time
yeah, it is configurable. We do it instantly after processing the previous file. And if we did not find any new files, there is some backoff that is configurable.
Yeah. Okay. Other question, just on the parallelization of window functions, is that just the same number of threads as dictated by max threads?
Yeah. It will use max threads, no surprises.
Yep. And another one, which I think we might have some good news for, is what are our plans around JSON now that we probably have decided to do something slightly new? Do you want to explain that, Alexei? Are we ready to start talking about that?
Absolutely. But
Good.
you have to talk about it with some care. Do not talk too much. So we have an experimental feature named JSON object data type. It was experimental for more than a year, and currently it is still experimental, and you know that experimental features should not be used in production. And the current status, we are going to get rid of this feature, sadly, but we found that it is not good from fundamental perspective. And we have to implement another feature that is currently in progress. It is based on a new data type named variant. And it uses a slightly different approach to unifying the semi-structured data. It will not try to do too much effort with conversion of data types. Instead, it will store the inferred data types for future reference. So if you have a column that sometimes it is string, sometimes it is number, sometimes it is array, it will store a variant of integer, string, array, and you will be able to do conversion on demand. And with this approach, we will avoid the complexity of early conversion. Instead, it is much more flexible. So we expect that the variant data type will be ready in first half of next year, and it will be a building block for the JSON data type that I also expect in the first half of next year.
Okay, that sounds like people are going to be quite excited. That's obviously no promises, but I'm sure the team will do their best. I think that's it. I'm looking. I can't see anything we've missed. No, I think we've got all questions. No, we've got a few more. We got some that popped up. So hub.docker.com is lagging on our build. Do we know if we're going to address that? Why our Docker hard image is 3 versions behind?
It should not be the case, but let's take care if you use the proper Docker name. It should be ClickHouse/ClickHouse. So for today, the latest version is 20.10 at this moment of time.
Yeah, I think somebody might be looking at the unofficial Bitami. Is it Bitami image? How it's pronounced.
No, in this case, it was that we pushed the 23.8 in addition to the 23.10 recently. So the tag shows up in the list a little bit higher. You can see 23.10 is below it. And 23.11 is, 23.11 is not there yet, but will be as soon as we push it live.
Okay, so it's an LTS patch, basically.
Yeah, indeed.
Okay, thanks, Tyler. Good spot. Is there support for subscribing S3 events with Kafka? I'm not quite sure what that means, but that was the last one.
So currently not. What does it mean, subscribing to S3 queue with Kafka? It is quite an interesting proposal. Interesting. I will try to explain it, and maybe I will explain a completely different feature than you meant. So imagine you have a Kafka queue, and it contains the references to blobs on S3. And you want to subscribe to Kafka to get these URLs and process every URL by running insert select query from S3. Currently, we don't have this feature, but it is quite tempting to implement.
Sounds like a good idea. So as a final one, maybe we always do a release post to highlight what we think are the most important features in the release. But I'm actually curious to hear if the community have any ideas of what they would like us to write about in the release post. So if anybody has any of the features that they found most exciting from Alexi's presentation, just chuck them in chat and that'll influence our decision.
You know what? Actually, I did not cover the most exciting feature of the release 23.11 because I wanted to keep it for myself. Don't expose it too early, but it is really exciting.
But you're not going to tell us.
Yeah, I will not tell you. I covered it on the boring stuff.
Okay. Well, on that note, we'll have to wait till next month, and I'm sure we'll find out then. Okay, Tyler?
Amazing. Yeah, thank you. For all those who have submitted questions, we appreciate it. For all of you who have attended live, you are what makes an event compelling. And for those of you who watch the recording of this later, thanks for that too. The video will be live soon on YouTube. I have a feeling we're going to want to take that S3Q demo and break it out into its own thing shortly. The blog post will be here in the near-ish future. Hit up Dale or myself if you have ideas of what you'd love to see covered. In the meantime, feel free to join us in Slack, clickhouse.com/Slack to join our Slack group and join a meetup group near you. We have 3 more coming up next week in New York, Boston, and Sydney. That's meetup.com/pro/ClickHouse. we have one more community call coming up in this calendar year. Between now and then, if you have ideas, bring them to us. If you'd like to maybe share an example of something that you've been working on that the community might be interested in, let myself and Alexei know, and we will see you at the next iteration. Be well, everyone.